The use of excavations is common in industry. Excavations can vary widely in shape and size depending on the work situation. It's an officer's responsibility to ensure that employers comply with the regulations. The first step in understanding safe excavation work is to define the terminology. A bulk excavation refers to excavations wider than 12 feet, such as basement excavations. Sloping, a system where the sides of an excavation are flared to a safe angle. Shoring, a support system designed to keep the sides of an excavation from caving in. A trench support structure, other than those designed by a professional engineer, will include uprights or soldiers, stringers or wales, and cross braces or trench jacks. What are the forces that affect soils? The downward or vertical stress is created by the weight of the soil. The horizontal support is provided by the surrounding soil. If the stresses are equal, the soil is stable. Once a cut is made, the stresses become unequal, and the rate of collapse depends on the soil strength and on one or more of the causes of soil instability. There are 6 main causes of soil instability. An increase in the depth of the cut. Saturation or increase in the water content of the soil. Hydrostatic or water pressure in ground cracks near the walls of the excavation. The weight of the excavated material and the equipment adjacent to the excavation. Shock and vibration from machinery, traffic, or blasting. And frost action. When collapse occurs, the fracture point will usually occur at a point back from the face which is equal to 1/2 to 3/4 of the depth of the excavation. The key to stable faces is to ensure that the stresses imposed are weaker than the soil strength. This is not something that can be simply left to one's judgment, because there are too many factors involved. Most problems with excavations result from one or a combination of the following reasons: inadequate sloping or shoring, lack of shoring knowledge, poor maintenance of shoring, defective shoring materials, excavated material too close to the edge, undercutting of trench walls, unexpected or transient loads, vibration and water.
Thank you. Thank you very much.
There are rules that must be taken into account before work on an excavation begins. All excavation work must be carried out in accordance with the industrial health and safety regulations or with the specifications and requirements of a registered professional engineer. Utility services in the area, such as electrical, gas, steam, water, and sewer, must be located and assessed for hazard potential. Pointed tools must not be used for probing to locate underground gas lines or electrical facilities. Trees, utility poles, rocks, or similar objects in the vicinity must be secured or removed, and a clean, level area extending 2 feet back from the edge of an excavation must be maintained. The side of the excavation must be trimmed or scaled to remove any loose material or rocks. Safe access must be provided in the immediate area where workers are employed in trenches over 4 feet deep. Ladders must extend from the bottom of the excavation to at least 3 feet above ground. Another consideration when excavation work is being done on a traveled roadway is the need for traffic control and high visibility clothing. Any engineered excavation support system must have certified design documentation available on site. Workers shall not enter any excavation over 4 feet in depth unless the sides of the excavation are sloped to a safe angle. The sides have been supported by the use of sheet piling or shoring and bracing, meeting the minimum standards contained in the regulations, or the workers are protected by other effective means, such as restricting worker access to the hazardous area. When sloping is used instead of shoring, depending on the conditions, no slope can be steeper than 3 feet horizontal to 4 feet vertical. When a combination of sloping and shoring is used, the minimum amount of shoring must be equivalent to the standard for the overall depth of the excavation. Shoring is installed from the top down and removed from the bottom up. The reason is so workers will always be protected by the shoring that's in place. In other words, the trench is excavated. Uprights, upper stringers, and cross braces are put in place. Then the lower stringers and cross braces are put in place. The number of stringers and cross braces needed is dependent on the depth of the excavation. When the job is finished, the lowest cross braces and stringers are removed first, and then the uprights. In other words, in reverse order. Then the site is backfilled. But no workers are allowed in the trench to compact the backfill. Excavation support systems must be installed so that they are firmly in contact with the face of the excavation. This can be achieved by backfilling or blocking. Support systems must be inspected daily or more frequently if required, and must be maintained in a fully effective condition. This is the site manager's responsibility. Shoring uprights must extend above the top of the excavation by at least 1 foot, and must be as close to the bottom of the trench as is possible, but in no case more than 2 feet from the bottom. Steel trench jacks can be substituted for timber struts, but must equal the strength of the timber ratings in all instances. Trench jacks are to be installed horizontally and perpendicular to the strut. Upper cross braces shall be installed within 2 feet of ground level. If the trench depth is up to 8 feet, 2 sets of stringers and cross braces are required. For a trench 8 to 12 feet deep, 3 sets of stringers and cross braces are installed. A 12 to 15 foot trench will have at least 4 sets of stringers and cross braces securely placed. Hydraulic or pneumatic trench jacks can also be used as long as a system is in place that will ensure that the integrity of the jacks is maintained in the event of a loss of internal pressure. Shoring uprights must not be inclined outward more than 15 degrees from the vertical when viewed along the trench. When the shoring requires the uprights to be close and tight, some of the uprights can be substituted by plywood with the following conditions. The plywood is 3/4 of an inch thick or thicker. The trench is not deeper than 9 feet. The uprights are installed at not over 24-inch centers. And the cross braces do not bear directly onto the plywood, but onto the stringers and uprights. Using the trench support structure table, we're going to select the correct components and build a shoring system. Here we have a trench in soft, sandy, filled, or loose soil. It's 13 feet deep and is 7 feet wide. What is the size and maximum spacing of the uprights required? By referring to the table, we see that for this 13-foot deep trench that's in soft, sandy, filled, or loose soil, we need 2 by 10 uprights that are close and tight in spacing. What size and maximum vertical spacing is required for the stringers? By referring to the table, we see that this 13-foot deep trench that's in soft, sandy, filled, or loose soil will need 8 by 8 stringers that are spaced a maximum of 4 feet on the vertical. What size of timber and the maximum vertical and horizontal spacing is required for the cross braces? By referring to the table under the cross braces columns, we see that for this 7-foot wide trench, we need 8 by 8 cross braces spaced a maximum of 4 feet vertically and 6 feet horizontally. By using this method as an example, go to the shoring component workshop in the workbook and determine the shoring requirements for each situation. When finished the workshop problems, restart the video and the correct answers will be given. Situation number 1. The soil is hard and solid. The depth is 8 feet. The width is 9 feet. Uprights, 2 by 10s, spaced 6 feet apart. Stringers, 4 by 6s, spaced 4 feet apart. Struts, 6 by 6s, spaced 4 feet vertical, 6 feet horizontal. Situation number 2. The soil is soft, sandy, filled, and loose. The depth is 8 feet. The width is 4 feet. Uprights, 2 by 10s, close and tight. Stringers, 6 by 8s, spaced 4 feet apart vertically. Struts, 6 by 6s, 4 feet vertical, 6 feet horizontal. In this situation, the close and tight 2x10s can be substituted with plywood as long as it is at least 3/4 of an inch thick, and there are 2x10 uprights spaced at 2-foot intervals.